Hello lovers of giant kick drums. Welcome to my first ever video for class. You are looking at an 1176 kit that I am building in the basement. I am in my basement. And the topic of today's video is the safety ground. If you look at the back of this IEC connector, you will see three conductors. The first is the hot. This is the power from the power company. The one on the other side is the neutral. This is the return path making a circuit to the power company. The one in the center is the safety ground, and that's what we're talking about today. The safety ground has two purposes. Purpose number one is, of course, safety, and purpose number two is for shielding and to shunt electromagnetic energy to ground. Now, how does that work? Well, say I'm using this 1176 next to a refrigerator, and there's a giant magnetic field oscillating, and that information, that hum, gets into my beautiful audio circuitry. We don't want that. So instead, we enclose the compressor in a metal box. Any electromagnetic energy gets on the chassis, which then shunts to the safety ground via this green wire. See, there's a screw connecting the green wire, and that's the safety ground of the IEC connector. And I've sanded down the paint on the chassis so it's very, very low impedance. It's very easy for the current to travel to the safety ground. So there's another half of this, which is an incoming XLR cable plugged into the device and plugged into this XLR connector here may also be carrying electromagnetic energy on its shield because it is traveling by the refrigerator as well. So what I've done in order to shunt that energy to ground from the shield is I have tied pin 1 from the XLR to the chassis of the connector, which is screwed to the chassis, and you can see I've also sanded the paint down there too. So there's a very low impedance ground from the XLR shield to the connector, to the chassis, to the green wire, to safety ground, and bye-bye our electromagnetic energy. Now, the other half of this is safety. The more important half, of course, is safety. So how does that work? Well, say I were to drop this 1176, and say the black wire, which is the hot, is carrying 120 volts, breaks off and touches the chassis. I touch the chassis and get electrocuted. That's not good. I don't want that. So what the safety ground does is it saves me from this, because the black wire carrying 120 volts of potential touches the chassis, which immediately shunts it to ground through the green wire and the safety ground. That is a short circuit. It's very low impedance ground. There's no resistance. High current, because the lower the resistance, the higher the current. That quickly overheats the green wire, and more importantly, it overheats the circuit breaker in my box. So here is your breaker box, like every house has, and you can see there are lots of different breakers. Some are 50 amp, some are 20, some are 15. I'm plugged into a 15 amp breaker. It quickly overheats. It's thermal. When it gets too hot because of the current pulling through at such a high amperage, it throws it, pop, and I don't get electrocuted. And hopefully all this happens before I ever touch the box. I plug it in, it overheats the breaker, hopefully quickly, before I get shocked. That's how the safety ground protects you and also shunts EMF to ground. Hope you understand.